Hello, this is Jennifer Dassinger with A Plus College Ready, and I'm here today with you to go over Unit 5, Bonding Molecular Geometry. This is the last unit of Semester 1, and this is 30 multiple choice questions that are from previous AP exams. So teachers, please feel free to change these questions into free response questions for practice for your students. Let's dive in. Question number 1, solid ethyl alcohol is best represented by what bond type? Well, all alcohols contain hydrogen bonding, and the hydrogen bonding is an intermolecular force where you have oxygen from one ethyl alcohol attached to a hydrogen with an intermolecular force to another ethyl alcohol because there's more than one molecule there in the solution or in the solid in this case. So our best answer for number 1, of course, is going to be C. It has hydrogen bonding. Number 2, silicon dioxide is best described at what bond type? Well, silicon dioxide is basically sand, and there's 2 common compounds that are used on the AP exam that we refer to for network solids, and network solids that are covalently bonded. So A is our best answer because, of course, the silicon and the oxygen are covalently bonded to each other, even though silicon is a metalloid. All right, so we'll look at question number 3. Question number 3 is giving you a boiling point chart. And in the question, it asks you, explain why hydrofluoric acid has the highest boiling point. Well, the reason why we know is look at the other acids. Hydrochloric, bromic, and hydroiodic are all strong acids, so B cannot be the answer because hydrofluoric is weak. We also know that hydrofluoric acid is a very dipole acid. That fluorine is so electronegative, it creates a high dipole moment, so C cannot be the answer. And we also know that hydrofluoric acid is used in a lot of cleaning substances and in etching glass, so D cannot be the answer. So A is the answer. And we also know, if you want to know a little trick, that FONH, if you need to, fluorine, oxygen, and nitrogen from one molecule will be attached to a hydrogen within another molecule. So remember, you're going to have multiple molecules of this hydrofluoric acid. Again, hydrogen bonding, intermolecular force. Question number 4. Melting point of magnesium oxide is higher than sodium fluoride. In this case, when we're looking at melting point, we're going to focus on the anion aspect because that's where you're going to see the polarity. And in this case, because these are ionic, who can gain the most amount of electrons? And of course, oxygen and magnesium oxide is technically more negatively charged than fluorine. So therefore, question number 4, B is the best answer. So the higher the electronegative charge, the higher the melting point. Question 5. CH3CH2OH is another way to write ethyl alcohol. And if you notice, it has 78 degrees Celsius, it boils, and then you have ether, and it boils at a negative 24. Well, these two substances both are isomers of each other, which means they both have the same ratio of elements in the compound, in this case, the molecule. However, they have different boiling points. And the reason why they have different boiling points is because of letter D. Again, it goes back to what we talked about in question number 1. Question number 1 again, and number 5 is ethyl alcohol has hydrogen bonding because of that OH group. Ether is not going to have hydrogen bonding. So D is our answer for number 5. Number 6, in which of the following processes are covalent bonds broken? Well, if you remember what I said about silicon dioxide earlier, you know what the answer is in number 6, D, a diamond. The first two parts, A and B, are just physical changes. And then, so is letter C, that's ionic, so that can't be the answer. So D is our best answer because diamond to graphite, or the G, that is going to be, again, a classic example of breaking those network covalent bonds. All right, let's move on to our next set of questions. Questions 7, 8, 9, and 10 are going to be using our choices A through D. So question 7, what is used to explain why iodine molecules are held together in a solid state? Well, iodine is a nonpolar substance, and in its solid state, it is going to be held together with these bonds that are intermolecular forces in terms of London dispersion forces. Because it's nonpolar, it's going to exhibit the intermolecular force of London dispersion. Excuse me. Number 8. What is the best explanation why the boiling point of hydrofluoric acid is greater than the boiling point of hydrobromic acid? Again, this is what we answered in a previous question of number 3. Hydrofluoric acid is going to have hydrogen bonding. So A. 9. What is used to explain the fact that 4 bonds in methane are equivalent? If you draw methane, C is our central atom, and you have 4 hydrogens bonded around it. So again, the best answer that is going to answer this is going to be B. And the reason why it's B is because they're equal and opposite to the central atom through hybridization. All right, and question number 10, last but not least, what is used to explain the fact that carbon-to-carbon bonds in benzene are identical? Well, benzene is this hexagonal structure that represents a resonance shape. So our answer is D, and the reason why it's D is because it contains a series of double bonds with single bonds, and it has actually a bond order of 1.5. So therefore it creates that hexagonal evenly shaped structure. Number 11, 12 and 13, we're referring to A through D again. Okay, so which diatomic species has the largest bond dissociation energy? So the question is really asking, who is harder to break the bonds? Well, if you draw the Lewis structures of these diatomic molecules, letter C contains a triple bond. Yes, nitrogen to nitrogen has a triple bond. Therefore, it takes more energy to break a triple bond than it does a double bond, like in oxygen, or a single bond, like in fluorine and boron. All right, number 12, which diatomic species has a bond order of 2? And our answer is going to be D, because oxygen has a double bond and it has 2 bonding sites. So therefore our bond order is going to be 2. So D is our answer. 13, which diatomic species contains 1 sigma and 2 pi bonds? Well, that is the basic definition of our hybridization of our triple bond. Yes, a triple bond contains 1 sigma, which is, remember back from your electron configuration and orbital notation, in the orbital notation with arrows, it is the s and the p orbits that are overlapping. So in that triple bond, you're going to have one s and 2 pi orbitals overlapping. All right, let's move on to 14. 14 is using the data table that we have with our bond energy. And then we are given an equation. So it's asking us to calculate the bond energy. Now in bond energy, our equation is, we call it the backwards equation, if you will, because in thermochemistry, you learn Hess's law. Well, in bond energy, it's the sum of the reactants, which is bonds broken, minus the sum of the products, bonds formed. So that's your equation. So you have to use the data table, and you look at that iodine is a reactant, so therefore you're going to take iodine, 150. You're going to put that in a bracket, then put a parentheses around 150, and then you're going to add 3 times 240 because there are 3 moles of your chlorine atoms. So 3 times 240. So you're going to add those two together, those two substances together, 3 reactants, minus, now notice you have 2 moles of ICl3. That means you have 2 moles times 3 210. So it's like 210 plus 210 plus 210. And that will be in another bracket. So when you plug that in, your final response will be a negative 390 kilojoules technically per mole. And so the best answer is B. If you need to pause the video and work that out, please feel free to do so and see the PowerPoint for more information. All right, 15. Which of the following molecules has the shortest bond length? Again, we've talked about breaking up bonds earlier questions. So 15, draw the Lewis structures. And again, a triple bond is going to have a shorter bond than a double bond or a single bond. And we know who has the triple? Letter A, nitrogen to nitrogen. 16. Which of the following compounds is ionic and contains sigma and pi covalent bonds? Well, first of all, we have to look who contains a metal. So we can eliminate B and C. Now you're down to A and D. Well, when you draw the Lewis structures, the sodium cyanide, letter D, between the carbon and the nitrogen, you're going to have a triple bond. And a triple bond has 1 sigma and 2 pi bonds. All right, 17. The Lewis structure has 2 unshared pairs of electrons on the central atom. Well, think water. We know our classic structure of water. There's our central atom of oxygen, 2 hydrogens on either side with 2 unshared pairs. Well, who best represents that out of our list? A, hydrosulfuric acid. And so A is the same structure as water. So think about water, substitute the oxygen with sulfur, and there you go. 18. It wants to know which one of these has a planar configuration. So you'll have to draw them with the Lewis structure. And A is our only answer because boron trichloride, once drawn, has boron as the central atom and 3 chlorines around it. Remember, boron only has 3 valence electrons. So it doesn't follow the octet rule. It's one of those exceptions. 19. The Lewis dot structure of which of the following molecules shows only 1 unshared pair of valence electron? So again, you have to draw the structures. And when we look at number 19, after you draw them, you're going to see that ammonia, NH3, letter C, has 1 unshared pair around the nitrogen. Number 20. It gives you a series of molecules and wants to know which of does not describe any of the molecules above. So you're going to have to draw them and then look at their VSEPR structures. And we see that chlorine carbon tetrachloride is going to have a tetrahedral shape. So that matches up. Carbon dioxide is going to have a linear shape. So that matches up. Phosphorus trichloride is going to have a trigonal pyramidal shape, and that's not one of our choices. Okay, so that can't be it. Then phosphorus pentachloride, when you draw it, is going to be a trigonal bipyramidal. Well, that's not one of our choices either. So sulfur hexafluoride is going to be our only choice. And it does not match up, and that matches up with octahedral. So square planar, there's no example of it. So C is our answer. And an example of a square planar would be xenon tetrafluoride. All right, 21. Pi bonding occurs in which of the following species? Draw the Lewis structure. So when you draw the Lewis structure, obviously who does not have a pi bond, and that is going to be